Hi there, this is Teacher Naihma and welcome to today's video. Today we'll be talking about the formation of light and heavier elements, and we will focus more on the chemical formulas involved here. Now I hope that you have thorough knowledge, or if not thorough, then a little bit of a background on the Big Bang Theory. Now, as you may have known, the Big Bang Theory is not exactly an explosion in space, where the universe began or when the universe began. Instead, it is the expansion of space, which is still happening right at this moment, and where the space in between things is getting bigger and bigger at all times. Now let's go to the Big Bang nucleosynthesis. The Big Bang nucleosynthesis is also known as the primordial nucleosynthesis. It is a process of producing light elements during the Big Bang expansion. And it was not really developed, but the calculation of the proportions of neutrons and protons was actually presented or developed by Ralph Alpher. And this process actually began 100 seconds after the Big Bang, and one process approximately lasts for about 3 minutes. And this whole process produces about 2 isotopes of hydrogen, 2 isotopes of helium, some lithium atoms, and beryllium isotopes. But we'll focus more on the stable elements that are formed through this process, not so much on the unstable isotopes. So let's go to writing an isotope symbol. Now, in writing an isotope symbol, you will have the element right in the middle. This will be your chemical symbol of the element. This one right here on the lower left box will be your atomic number. And on the upper left box will be your atomic mass or mass number. Does that make sense, right? So, like for example, if you look at your periodic table, I hope you have your periodic table with you. If you look at your periodic table, let's use carbon as an example. So carbon. The chemical symbol of carbon would be C. So what will be put on the lower left side of C? That would be the atomic number. And the atomic number of carbon is 6. Now, what about the mass of carbon? The atomic mass of carbon, according to your periodic table, will be 12. So that's how you write an isotope symbol. Now let's go over some rules that we have to follow with regards to the protons, the neutrons, and the number of electrons that are found in a stable element. Okay, so let's start with the atomic number. The atomic number of your element is unique. Now, if you look at your periodic table is numbered from 1 to 100 plus, right? So each slot or each number is unique to one element. So that means the atomic number does not change for that element. The atomic number is basically the number of protons. So therefore, the number of protons actually dictates what element that is. I hope you get that. So for example, if you use carbon, carbon has an atomic number of 6. Therefore, the number of protons that are found in carbon are 6, right? Makes sense. So that is the number of protons. Now, the atomic mass, on the other hand, is basically the number of protons plus the number of neutrons. Now, why is that the case? A proton weighs about 1 AMU, or atomic mass unit. And the neutron actually has the same mass, 1 AMU. So they're the only subatomic particles that constitute the atomic mass. What about the electrons? The electrons, not so much, because they're very small. They're very negligible. So they don't really add up to the atomic mass. So therefore, if you analyze that, if you subtract, okay, so if you have the atomic mass minus the atomic number, which is basically protons plus neutrons minus protons, you will get the number of neutrons. Makes sense, right? And then, what about the electrons? Well, in a stable element, like an element that has no charge, like zero charge, the number of electrons will be the same as the number of protons. So that's it. So those are the rules that we have to remember all the time. And maybe you're not adept to memorizing them now, but later on, when you practice, when you get to practice and practice with all the worksheets that you're going to do in the future, you will get to memorize it without any effort at all. So this is the whole um, plane of rules. Okay, so just remember that. Now, let's start with the deuterium. Now, because of the Big Bang Theory, according to the Big Bang Theory, there was this expansion, right? And there were subatomic particles just floating around, and they will readily react with one another. Okay, so then came deuterium. Deuterium is very hard to pronounce. Deuterium. Now, deuterium is actually an atom that is that consists of your proton. You have a proton and a neutron. So basically that. And then you will produce deuterium. Now, when this happens, this is a nuclear reaction. You will also produce high-powered photons. And we will add there your gamma rays. So this is actually your gamma ray or your high-powered photon. So this weighs about 1 AMU. This is 1 AMU. And this is, if you add both of them, you'll get 2 AMU. So your deuterium approximately weighs about 2 AMU. Okay, and then you have another one. All the subatomic particles, they're able to react with one another on space. So you have this thing called tritium or tritium. Now, a tritium is basically a deuterium reacting with another deuterium. So in this case, you will have a proton and a neutron reacting with another proton and a neutron. So when that happens, you will actually make tritium. So what is tritium? That's basically a proton plus a neutron plus a neutron plus a proton. Okay, so there's a free proton floating around there. So in this case right here, if you look at your periodic table, if we go back, okay, let's go back to deuterium. If we go back to the deuterium, because it has one proton and one neutron, if it has only one proton, what is that? What element is that? So again, if it only has one proton, its atomic number will be 1. So if you look at your periodic table, what element has an atomic number of 1? That would be hydrogen. Now, hydrogen will have 1 proton. Now, how about the mass? So 1 AMU plus 1 AMU, now how many is that? 1 plus 1, that's 2. So this is an isotope of hydrogen, that's deuterium. Tritium is also an isotope of hydrogen. Why? Because how many protons do you see here? There's only 1, right? So 1 proton will be atomic number 1, and that is hydrogen. Now, how much weight, how much mass does it have? So you have 1 AMU plus 1 AMU plus 1 AMU. How much do you get? So if you write that as an isotope symbol, you will have 1 here, then you will have the atomic mass of 3. So this is another isotope of hydrogen. Yeah, I hope you still get it. So that's tritium. Now, when I talk about or when I discuss the formation of light in heavier elements, I like to divide them into 3 reactions so that you won't really have a hard time analyzing these reactions. In the first reaction, we're actually making deuterium. Now, if you go back, we have already discussed that. So that's basically a proton reacting with a neutron to produce deuterium plus gamma rays, so high-powered photon. So basically, that is the skeleton of our reactions. So from here on, we're going to go to the second reactions, and that is the formation of hydrogen 3. Hydrogen 3, why is it called hydrogen 3? We'll find out. I'll show you later. Okay, so imagine that there are free deuteriums floating around in space, and they readily react to protons and neutrons. So for now, let's try a deuterium reacting with a neutron. Okay, now let's analyze this. Now in deuterium, you know that deuterium is a combination of proton and neutron, right? Okay, now the neutron is basically just a neutron. And then you combine that, what do you get? So you have a proton, a neutron, and a neutron. Now, what element has 1 proton? Because it's only 1, right? That would be hydrogen. Now, how much does the hydrogen weigh? Or what is its mass? So you have 1 AMU here, plus 1 AMU here, plus another 1 AMU here. So how much is that? 1, 2, 3? That's 3. That's why it's called hydrogen 3. And then gamma rays. So that is hydrogen 3. That's why it's called hydrogen 3, because it's a type of hydrogen that has an atomic mass of 3. Now, if you look at the periodic table, a stable hydrogen does not have the same atomic mass. It only has 1 as an atomic mass. So again, this is an isotope of hydrogen. Now, the next one is the creation of helium-3. Okay, so if we have let deuterium react with a neutron earlier, right now we will let deuterium react with a proton. So what happens there? Now, let's break it down. So deuterium has a proton and a neutron. Okay, and then we bring this down here. We have a proton right here. So let's determine what element this is. So how do we determine? We're going to count how many protons there are. So how many protons are there? We have 1 and 2. So that's 2 protons. So what does that mean? what will be the atomic number? The atomic number will be the same. The atomic number will be 2, right? Since there are 2 protons, this will mean the atomic number is 2. And what element is that? That would be helium. Okay, so that is helium. Now, next, let's determine the atomic mass of helium here. Now, it's very easy. You just count how many of these or how much AMUs are found here. So you have proton, which is 1 AMU, neutron is 1 AMU, and another proton is 1 AMU. So 1 plus 1 plus 1, you'll get 3. So that will become 3 helium. And then there is gamma. I hope you still understand. If you were lost in translation somewhere over there, you can just rewind and then watch it again. So that is second reactions. Now, actually, we're not done yet. Why? Because we will let 3 hydrogen and 3 helium react with a neutron and a proton. Okay. So what happens here? We're actually making helium-4. Okay. So there are actually 2 ways on how to do that. So let's ready them here. So the first one is you take the products from the previous slides, right? So you have, let's say 3 helium right here, and then the other one is 3 hydrogen. Now, what if 3 helium reacts with a neutron? So what happens here? Now, let's break it down. Now, 3 helium, there are 2 protons here. You have a proton and a proton. No, not 2. I'm sorry, not 3, but 2. 2 protons here, and then you have 1 neutron. Now, what if you add another neutron? So what happens? You will get around 2 protons and 2 neutrons. So it's the same, right? So you have 2 protons, and 2 protons is actually atomic number 2. So what is atomic number 2? What element is that? It's still the same. It's still helium. Now, let's determine the atomic mass. So you just have to count how many 1 AMUs there are here. So you have 1 for this one, another one here, another one here, and another one here. So 1 plus 1 plus 1 plus 1, you'll get 4. So that's 4 helium. And then that's gamma. Okay, so you have made a 4 helium here. Now, what about if we have a 3 hydrogen? A 3 hydrogen will react with a proton. Now, let's break it down. Now, hydrogen has how many protons? This is atomic number 1, right? So there's only 1 proton here. And then, how many neutrons are there? You'll have 2 neutrons. So you add them all together, you'll get 3. So what if you add another proton to the mix? Okay, so first let's determine what element this is. So for you to determine what element this is, you just have to count how many protons there are. So how many protons are there? So you have 1 proton, another proton, so you'll have 2 protons. So again, 2 protons is atomic number 2, and that is helium. So you write here helium. Now let's determine the mass. So you just have to add all of these. So you have 1 here, another here, another here, another here. So that's 1 plus 1 plus 1 plus 1. You'll get 4 helium plus gamma. So you have another 4 helium. Now let's go to the third reactions. Now in the third reactions, it's sort of a continuous thing. it's very important that you get to look at your periodic table, and then you get to see the atomic mass and the atomic number numbers in the periodic table. Now, in the third reactions, you will have, or you will get the products from the previous slide. Like for example, you have a 4 helium reacting with another 4 helium. So you just have to break it down if you still have, or you're still having a hard time determining what element this will be. Now, you know that with the masses here, you can just add the masses. So that's 4 plus 4. So you'll get 8 here. Now, let's determine what element this will be. Now, helium has an atomic number of 2. So that means there are 2 protons. So there are 2 protons here. And then you add another helium, that's another 2 protons. So you'll get 2 plus 2 protons. That will be atomic number 4. And what element is atomic number 4? That will be beryllium. Now, the thing about beryllium is, if you look at the periodic table, the atomic mass of beryllium is not 8, right? It's not 8. Now, I leave you to know, I will let you know what, I will let you find out, sorry. I will let you find out on your own what the atomic number is. Or sorry, not the atomic number, but the atomic mass. But let's establish that beryllium does not have an atomic mass of 8. So this becomes unstable. Now, what happens here? If it becomes unstable, it will just break down into its components, into 4 helium and 4 helium. So it will just go back to being 2 4 heliums. That's it. That's pretty sad, isn't it? Now, what about if these 2 4 heliums react with another 4 helium? What happens then? So let's determine the mass. That's 4 plus 4 plus 4. You will get 4 plus 4 plus 4. That is 12. Okay. Now let's determine what element this is. So helium is atomic number 2. So 2 plus 2 here plus 2 here, then you'll get 6. Now, what is the element that has an atomic number of 6? That will be carbon. Now, if you look at your periodic table, what will be, or what is the atomic mass of carbon? Isn't it 12? So that means this is stable. This is a stable isotope, so it will not break down anymore. So in this process, it will release gamma rays. Now, let's take 12 carbon and let's have it react with another 4 helium. Let's try to see, okay? We have 12 carbon plus another 4 helium. Let's try to see what we're going to get. So let's determine the mass first. That's 12 plus 4. That you will get around 16. Not really around, but exactly 16. And then let's determine the element. So carbon, because it has an atomic number of 6, it will have 6 protons. Helium, on the other hand, will have 2. So 6 protons plus 2 protons. What do you get? 6 plus 2, you will get 8 protons. So what element has an atomic number of 8? That's correct. That's oxygen. And then oxygen, because it has an atomic mass of 8, this is stable. So you'll write the gamma rays here. I'm going to erase this because I'm lacking space. Now, what about if we continue? What about if we continue? What about if we get 16 oxygen and then let it react with 4 helium? What about that? So 16 plus 4, that's 20. And then oxygen has an atomic number of 8. And then helium has an atomic number of 2. So 8 plus 2, you will get 10. And atomic number 10 is what element? That will be neon. And that is stable. And what about, this will be the last one. And what about if we take 20 neon and let it react with a 4 helium? So 20 plus 4, you'll get 24. And then neon has an atomic number of 10. Helium has an atomic number of 2. So 10 plus 2, that's 12. So what element is that? That's magnesium. So we'll just end there because this will continue for a very, very long time until you reach the last of the elements in your periodic table. But this is the easier way of understanding the chemical formulas that you encounter in under this topic. And I hope that you'll learn something from this, and I hope that you will be able to analyze more if you get to read more chemical formulas under this topic in the future as you go study for chemistry, or in this case for physical science. So thank you so much for watching. If you need more help, you can just write your comments here under the video here on YouTube, or you can message me. For my students, you can just message me or email me in our Gmail or in our Google Classroom. So I hope you have a good day, and you can just rewind if you do not understand. So thank you so much for watching, and I'll see you next time. Goodbye.